Kia ora team, this is Mr. Dharma, and today I want to talk to you about anti-differentiation. Let's quickly talk about differentiation. So we have a function, x squared plus 7x, and we can differentiate this by multiplying by the power and taking one off the power, and multiplying by the power and taking one off the power, and we get the derivative. This method here is called differentiation. Now what we're going to look at is going the opposite way. So to go the opposite way, well, let's start with the derivative function. And what do we tell ourselves to get to the anti-differentiated function? Well, let's have a look. We had multiply by the power, take one off the power. So let's do the opposite. What's the opposite of taking one off the power? Well, let's add one to the power and then divide by the new power, because this is the opposite of multiplying by the power, isn't it? So add one to the power and divide by the new power. This should give us back to what we had. So let's see. Add one to the power, divide by the new power. Add one to the power, divide by the new power. Did we get what we wanted? Yes, we did. But what happens in anti-differentiation is sometimes there can be multiple functions that lead to the same derivative. So let's have a look. If we had f of x was equal to x squared plus 7x plus 1, its derivative would also be 2x plus 7. And so this 1 is lost. And so when we anti-differentiate using add 1 to the power and divide by the new power, we don't seem to get that 1 back. And so what they decided in maths is after you do add 1 to the power and divide by the new power, you must plus c. So you're adding a constant of integration because you don't know what information was lost as a constant. So every time you anti-differentiate, you must add a c at the end. Okay, that's really, really important. Okay, so let's try another one. If I gave you 3x squared plus 8x plus 9, well, let's anti-differentiate this. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and plus c. We can simplify this. X cubed plus 4x squared plus 9x plus c. Now what I'm going to do is show you how we can find this c. Suppose I said to you, find f of x if f dash of x is equal to 4x plus 8 and f of 3 is equal to 5. Let's see if we can work this out. First off, we need to anti-differentiate. So we take our function and we're going to anti-differentiate. So we add 1 to the power, divide by the new power. We add 1 to the power, divide by the new power, and plus c. Okay, let's simplify this a little. That's 2x squared plus 8x plus c. Alright, now we know that f of 3 is equal to 5. So we're going to put 5 on the outside and make x equal 3. Okay, let's keep working. 3 squared is 9, times 2 is 18. 8 times 3 is 24. Okay, and so now you'll get 18 plus 24 is going to be 42 plus c, and then we can work out that c is equal to 5 minus 42, or c is equal to negative 37. Alright, so your function f of x is now equal to 2x squared plus 8x minus 37. Okay, and that is finding C. And typically you're asked to find C if you're given a question like this. If f prime of x is equal to something, and they give you a point on the curve, you can find f of x by substituting back. I hope that helped. I'll catch you later.